we're supposed to find like the degree of confidence, like 90%, 95% for this confidence interval. And if this wasn't p in the center, if this is x bar, or if this is mu, I should say, it's just a different confidence interval formula. Okay, the confidence interval formula for a mean, in case that's the one you're working on, it's x bar plus or minus t, if we don't know the population standard deviation, times the standard deviation divided by the square root of n. Since we are doing a proportion, our confidence interval is constructed by taking p hat plus or minus z star, which just means a z-score for a confidence interval, two-tailed z-score, times the standard deviation is a little bit different. It's p times 1 minus p over n. Okay, so two really similar formulas. This part right here is called the margin of error. This part right here is called the margin of error. And you can get the margin of error really quickly if you have a confidence interval, because the margin of error is the distance from your the sample value to one of the endpoints. So we can find out what p hat is. We could either take the average of these two endpoints, because the confidence interval is symmetric. So 0.523 plus 0.669, then divided by 2. So 0.596 was their estimate. Or you could have gotten p hat by taking these numbers on the end. There were 65 successes out of a total of 109 samples. So same type of thing. This one's just more accurate because it's got more decimals. But we'll stick with this p hat for this problem. So that's p hat, and we're actually going to plug that in for p, because that's our best estimate for the population proportion. And the margin of error, like I was saying just a second ago, it's the distance from your sample proportion, or your sample mean. It's that distance to one of the endpoints. So I'm going to take 0.669 and subtract it by 0.596. That gives me 0.073. And so now that I have the margin of error, I can make an equation. I can set the margin of error part equal to 0.073. And if I can solve for z star, I can use an online calculator to convert that to a percentile. So I'm plugging in, oh no, sorry, I plugged in the wrong thing. I need to plug in 0.596 for p. Then it's 1 minus 0.596 divided by n. There's 109. So let's do some calculator work here. I'm going to do 1 subtracted by 0.596 first, and then multiply that to 0.596, then divide it by 109, and then take the square root. So you get 0.073 equals z star times 0.047. And then to finish getting z star by itself, I'm going to divide both sides by 0.047. So z star is 0.073 divided by 0.047 gives us 1.55 if we round to the second decimal place, which is what our tables usually do. Okay, so what you would do if you're using the table is you'd go look up 1 on 1.5 in the leftmost column, and then see where that matches up with the column that has 0.05. That will be your percentile, where those two things match up. I don't like using the tables because with the internet's so readily available to us, we can just Google this with our smartphone. I'm going to search a z-score in Google. I'm going to search z-score to percentile calculator, because I have a z-score. I want to know what percentage of the area it represents. And a good one that comes up is measuringu.com. I'm going to plug in 1.55. It's already set to two-sided because we're dealing with a confidence interval. I'd click one side if I just wanted a left tail area. Yeah, sorry, and I didn't actually, I should have specified. If you look that up in the table, it'll give you the area for one of the tails. You'd have to double that and take it away from 100% to find out how much is in the middle. So this is way quicker, right, looking it up online. So about 88% is what this rounds to. Okay, so that will be our correct answer for this one. I think these are randomized, so you might not get the same exact question, but if you have the mean, if you're working on the one, excuse me, if you're working on the one with the sample mean, you're doing the same type of thing. You want to set that margin of error equal to whatever to the formula for the margin of error, and then solve it like an equation for t. And then to get the t value that you need, you could search in Google t value to percentile calculator. And then this one's good right here. Just remember, degrees of freedom is n. Oh wait, what is this? Oh yeah, this is the same one I was using in another video except for t. Degrees of freedom is just n minus 1. So if you had like 23 samples, you plug in 22. And then, oh, actually this one isn't going to work. This is in reverse. Even though I searched t-score to percentile, it gave me percentile the t-score. Let me check the next one. Yeah, this next one I think I've used before. So if you had 22 for your degrees of freedom, and if you had like a t-score of 2.20, you could click calculate, and it will give you the left tail probability. See how it's saying less than 2.20. So you'd want to subtract that from 1, and that would give you the right tail. And that's just one tail, so then you'd have to double that. Let me see if I can find a two-sided one, like the one we just used for Z. Usable statistics. Oh, this one says two-sided. So if your t-score is 2.20, your degrees of freedom is 22, let's say. It's got two-sided, so that third one I see on the list, that gives you the area in the tails. So this would be like a 96% confidence interval. Okay, so just I'll show you the address up here. I found usablestats.com was a good one for this one. It was the third one down when I typed in t-value to percentile calculator.